Well, I hope everyone is enjoying Notes 2023. I understand that literature reviews aren't everyone's cup of tea, but my presentation today addresses a much more universal challenge. How do we quickly analyze data in different formats, from different sources, with different information fields? As an added bonus, I'll provide a practical example on how to use machine learning vector embeddings to provide high precision. This presentation will be broken into three parts. The first part will quickly introduce the use case for computational literature reviews. The second part will cover using Neo4j to import, aggregate, and analyze metadata from a number of literature repositories, including OpenAlex. Finally, I'll discuss how vector embeddings generated using OpenAI can be used to find similar literature across multiple data sources using article abstracts. Please post any questions in the chat and I'll respond at the end of my session. The best part is everything covered today is freely available on the GitHub site listed here and posted in the chat. This site has the Jupyter notebooks used to import data into Neo4j using a combination of Python and Neo4j Cypher. To promote accessibility, the programming is functional with short scripts. Neo4j version 5.11 or higher is required, along with installation of the APOC plugin for full functionality. My goal in developing this literature review tool is to break free from the limitations imposed by query tools tied to a single platform or data source. This presentation is an extension of a paper I had published at the Hawaii International Conference on Systems Sciences, available at the link in the chat. A word of caution is the paper is very academic, but my presentation today isn't. The talk is focused on the how to for finding a needle in a stack of needles. The genesis for this project was conducting research for my PhD. Like many students, I wandered from topic to topic, trying to understand the current state of knowledge and identify gaps I could address with my research. I ultimately settled on the topic of cyber deception. Unlike many fields that have specific journals or dedicated conferences, the interdisciplinary nature of cyber deception, involving both technical and psychological components, results in literature on this phenomenon being widely spread. This was a considerable challenge to address as I began my research. In my literature review, I wanted to draw from a wide range of sources to minimize bias. Selection of a single source of data, regardless of how expansive, introduces bias based on how the data was originally collected, even for academic literature. Finally, I wanted to develop a repeatable process for conducting computational literature reviews for future research. As I set out on my PhD research journey, I familiarized myself with a number of tools available to search academic literature databases. These tools were incredibly useful, but tracking all potentially relevant work was a tremendous challenge across different platforms. In conducting literature reviews, researchers are faced with a trade-off between recall and precision. A search tool must balance retrieval of all potentially relevant literature against the delivery of only literature that is actually relevant. As I started investigating the use of various techniques to retrieve literature metadata, I realized I needed a flexible storage method that could be modified or updated as new sources of information were added. I also understood that the relationships between articles, authors, and topics were very important in finding relevant literature, which led me to store this data in a network graph. Neo4j was a natural fit, with the open source community edition able to easily support millions of nodes and relationships on a standard laptop computer, with cloud options also available. The core of this tool is the basic data model schema, consisting of nodes representing entities associated with a work and edges, which represent relationships between entities. This data model schema was developed to highlight the relationships between key entities associated with academic literature, including authors and references. Properties containing relevant information from available data fields can be added to both nodes or relationships to provide context to these entities. As a word of caution, data model schemas are flexible in network graph databases, but there are better and worse ways to create your model depending on how the data will be queried. Multiple data formats, missing data, different data fields, doesn't matter. Unlike a relational database, the data model schema does not need to be predefined and thus can be modified or updated as new sources of information are added. Any missing data can be automatically set as a null value. Nodes and relationship properties are optional, so there's no issue if information fields are different between sources of data. While manual entry of data is not the primary technique to import data using this tool, it is useful as a starting point to include existing personal resources or knowledge gained from gray literature. The same process described to manually create nodes, relationships, and properties is used to statically or dynamically import data, whether CSV, JSON, or XML formats. Create a node based on some identifier, specify the properties you want to associate with the entity you just created. Next, create relationships between nodes based on some connection between the entities. That's it. These steps can be as simple or as complex as needed based on your data and use case. This slide depicts static data import from Clarivate's Web of Science. Currently, access to this data is only available using a web-based portal to first look up the literature of interest, then download a spreadsheet of the results. This data is loaded into Neo4j using the load CSV command, creating work nodes using the merge command with the unique ID provided by Web of Science to prevent any duplicate nodes from being created. Despite containing 14 data fields, only the authors field aligns with the relationships in my data schema. The authorship property created for the work nodes is then unwound to retrieve individual author names, which are used to create individual author nodes. This slide depicts the import of data from both RxIV and Semantic Scholar. Both platforms have an API which can be called to retrieve JSON formatted results, with 16 data fields retrieved for both datasets. Each includes information on work, author, and concept, but only Semantic Scholar has information on works referenced and works cited to create these relationships. Using a combination of Python and Neo4j Cypher, we are able to create a parameter for each JSON data element, which are then imported as a node property into Neo4j. The Jupyter Notebooks use Python wrapper projects available on GitHub for querying these data sources, and also for OpenAlex, a fully open catalog of the global research system. Of all the data sets covered today, OpenAlex is by far the most comprehensive, with 58 data fields across work, author, concept, and institutions, enabling a rich set of relationships, including works referenced by and related to each other. These additional fields increase the size of the JSON data retrieved, so I constructed the Jupyter Notebook to first download all results from OpenAlex, then import the downloaded data into Neo4j, as depicted here, using the apoc.load.json command, with apoc.periodic.iterate running in parallel mode for faster data import. Works referenced and related to other works are provided in a list, with only the ID of the work provided. Using this ID, all information about works not originally included in the results, but referenced by them can be retrieved. My initial query on deception returned 23,000 works, but referenced and related works expanded this number by over 10-fold, with 265,000 additional referenced and related works added. This slide provides a snapshot of my current Neo4j database of deception-related literature, with almost 1 million nodes and 2 million relationships running on a regular laptop. With this data easily available at our fingertips, we can now conduct a comprehensive and systematic literature review. In investigating the intersection and evolution of scientific fields, this chart provides an example of exploring relationships between theories associated with computer deception and cyber deception, using simple keyword queries to identify articles related to these two areas, along with the most referenced resource containing the word theory. The real power of this tool is not in the keyword or key phrase search, but rather in the ability to query based on the relationships within the data being queried. This is a trivial example, but highly complex queries can be created using specific phrases related to concepts of interest, authors, journals, or any other combination of nodes, relationships, or properties. The table on the left highlights the 5 most referenced theories from articles related to computer deception, covering a wide range of theories, including interpersonal deception theory and channel expansion theory. In contrast, the table on the right, with the most referenced theories for articles related to cyber deception, game theory is the most influential. In conducting research, the importance of theory cannot be overstated. Theory helps provide the rationale for inquiry, defining the aim of end research questions, while providing a framework for data analysis and interpretation. This tool enables rapid identification of dominant theories in any field based on relationships and properties. This August, Neo4j introduced a native vector search capability, enabling users to gain new insights on their data through the use of machine learning techniques. Here we see the abstract for the most referenced theory article for cyber deception being transformed into a vector embedding using OpenAI. This text embedding measures the relatedness of text strings for use in search, recommendations, and classifications. The Jupyter Notebook provided to generate vector embeddings includes a cost estimate feature to ensure there are no surprises on your OpenAI bill. The cost to generate over 55,000 embeddings for article abstracts was about $3, which is quite reasonable for the capability provided. We can use vector embeddings to guide our literature review by finding relevant articles regardless of source, allowing researchers to balance recall and precision of results based on their needs. Searching for the top 5 results for theory references of cyber deception articles returns highly relevant results from the over 800,000 works retrieved. The power of vector embeddings is highlighted by the first result returned, the preliminary RxIV ePrint of the original article, which was originally published in the IEEE Communications Survey Journal. Thank you for attending my session today. You can connect with me via GitHub or LinkedIn if you'd like additional information or want to collaborate. For future work, I want to add parsers for additional sources of literature metadata, as well as incorporate Neo4j's Gen AI stack into the literature review tool to provide a locally run capability leveraging open source large language models without the need to send data to an external company. In exploring your own use case for Neo4j, do you need simplicity, flexibility, and scalability? If so, give it a try for a new perspective on your data. Okay, if there are any questions, please let me know. Please be sure to complete the survey for this session and enjoy the rest of Nodes 2023. Thank you for your time. See a question from Kent. Could you use the GDS embedding feature? Yes, and there was a really good webcast kind of comparing vector embedding or vector versus graph-based search by the Neo4j team that I think it really provides the flexibility depending on your use case if you want to use the GDS embedding or the new vector search capability. See, would you please the latest topics of doctoral theses regarding Neo4j? Wislaw, can you elaborate? I know there's been a number of papers, work specifically, using Neo4j. I know I used it for my own dissertation, looking at cyber deception data, being able to construct timelines of individual activity. But if you can send me a note, I'll respond to your question, because again, I believe it's a really powerful capability that Neo4j provides, as well as that their contributions to the open source community. And Jonathan, responding to your question about the developing the tool further, I think really trying to make it more user friendly. Right now it's just very basic coding, whereas there are a number of platforms. I think Streamline is one of them that creates a very user friendly interface for individuals who aren't comfortable with coding and Python to really leverage a lot of the powerful capabilities. I think also the being able to incorporate the large language models. There's work with the Gen AI stack where you're actually, you're able to generate Cypher query automatically for very complex queries. That Cypher is pretty user friendly, but it does take time to learn and understand. The second link, and again, I'm happy to collaborate with anyone interested in the tool. Thank you for the comment, Mark, about the link not working. I posted a second link there that's at the URI, so that should be accessible to everyone. Again, encourage everyone to complete the survey and hope you enjoy Nodes 2023.